So this afternoon, I want us to derive the formula for the first principle of differentiation. In differentiation, we have different techniques of solving differentiation. So we have the product rule, and the likes. So likewise, first principle too is just one of the techniques. So we want to derive the formula for first principle. So follow me and let's do this together now. So we have y equals to the function of x. So in this equation, f of x is an independent variable, while y is a dependent variable. So it means that the value for y is depending on the value for x. So whatever the value of x is what the value of y will be. So now, first principle is now about what? About the rate of change. The rate of change. So if there is a slight change in the function of x, automatically there will be a slight change in the function of y, because y is depending on f of x. So that change now represents what we call delta y or delta x. So now we have y plus delta y. This delta y is the change that occurs. Don't forget, the change initially occurs in the function of x. So definitely it usually affects these two. So we have equals to f or f plus delta x. So this represents the change, the rate of change. This as well to represent the rate of change. So what do we do next? We bring this y to this other side. So it's going to become, we have delta y equals f into x plus delta x, then minus y. So look at this y. From our equation, we have y equals to f of x. So instead of writing y, what I'm going to do, I'm going to plug in f of x. So it's going to become delta y equals to f of x plus delta x minus, so instead of writing y, we write our f of x. So we have minus f of x. So what do we do from here? We are going to divide both sides by delta x. Don't forget differentiation. It's going to must do with respect to. We are differentiating with respect to y. We are differentiating with respect to x from y with respect to x. So we are differentiating. We are going to divide both sides by delta x. So we have delta x over delta x. So now, to now find the instantaneous rate of change, we are going to what? Apply our limit. We are going to bring in our limit, whereby our delta x will be tending to 0. Our delta x will be approaching 0. So it's now going to become delta dy over dx equals the limit as what? As delta x is approaching 0. Then we now add this our equation. We have f into x plus delta x minus f of x, then over delta x. So this is the formula for first principle. So now let us use this formula, this same formula, principle, to solve, a question. I want to solve this question using the first principle. So now what is first? Don't forget, the rate of change. And the rate of change is represented with delta x, with delta y. So now we're going to have y plus delta y equals x plus delta x. And don't forget, our function of x is actually squared. So it means that we are going to square this. So now what do we do next? We have y plus delta y. We are going to expand this. We have x plus delta x and x is plus delta x. So we are going to multiply this. So it's going to become y plus delta y. So let's do this, step by step. So let's use this to multiply the whole of this. So it's going to be x into x plus delta x. Then this plus delta x into x plus delta x. So now we have y plus delta y equals x times x. We have our x squared plus x times delta x is x delta x. So we have x delta x. Then delta x times x is what? X delta x. So we have plus x delta x. Then plus delta x times delta x. How is what? Delta x all squared. So this square is affecting both the delta and the x. So now, this plus this, we can add them together. So we have y plus delta y equals to x squared plus x 2x. Delta, just take one of the delta. We have delta plus, then we have this delta x all squared. So now we can see that from this place, you can bring our y. Don't forget, from how we derive the formula for first principle. What happened to this y? bring this to this other side. Same thing implies here. So we are going to bring this y to this other side. So it's going to become delta y on this side equals to x squared plus 2x delta x plus delta x all squared. So when it comes to this side, it changes to minus y. And don't forget, what's our y? X squared. So we are going to replace this y with this function of x. So we have delta y equals to x squared plus 2x delta x plus delta x all squared minus x squared. So what do you notice? What are we doing next? This we cancel this. So we are left with delta y equals to 2x delta x plus delta x squared. So what are we doing next? According to the steps we did, we are going to divide both sides by delta x. So we have delta x over delta x. Then what are we going to do? So we have delta y over delta x equals, now looking at these two, delta x is common. So let's bring out that which is common. So we have delta x. So then what do you have left here? We have 2x. Now don't forget, this is 2 delta x here. So it's going to remain 1 since you brought out 1. So we are left with 1 here, delta x. Then we have over delta x. We have brought out delta x which is common. So what do you do now from here? So delta x can cancel delta x. So what do you have left? You have delta y over delta x equals 2x plus delta x. So what was the last step we did the other time? We now bring in limit. So it means that we are now to bring in limit as the delta is approaching 0. So it's now going to become dy over dx equals to the limit as delta x approaches 0. Then we have this 2x plus delta. So what are we doing next? We are now going to plug in 0 in place of delta x because it says delta x is approaching 0. So we now have dy over dx. So the moment we plug in 0 as delta x, then this limit will not be there. So it's going to become 2x plus 0. So our delta x now becomes 0 as a result of this limit as delta x is approaching 0. So we have now plugged in 0 as delta x, then this will not be there. Then delta x becomes 0. So now have dy over dx to be 2x plus 0. We have 2x. So this is our answer. Thank you very much for watching, and if you have any question, you can make use of the comment section. Share to your friends, follow me for more. Thank you very much. Bye.